Okay, students, so we start with lecture number 36, and I will solve some problems, stereographic problems, or problems with the help of stereogram, so that you understand the stereographic projections better. So that I think, and there are numerous sites, as I told you, to learn these, numerous books to learn this, so you can learn it online. But I think I will try and see whether I could do it, and this will be the focus of this lecture. Now, to begin with, there are two types of stereo nets. One is called the Wolf's net. Wolf's net, and the other one is called Schmidt net. You read about them, how they are done. One is called angle true, and one is called area true. So what is what is how it's done, you find out. The only thing what I can tell you is, so this is the stereograms that you have, and normally what happens, the stereograms are divided into numerous circles. These are called grid circles. So they are divided like this with 10-degree intervals for the whole net, and then you have this type of divisions, 10 degree, and so on. So from 0 to 90, there will be 90 divisions, and similarly it will have divisions like this for every 10 degrees. So this is how the net looks like. So you can while plotting for your stereograms, now you can of course do it on the what should I say, on the using certain softwares. When we learned, there aren't those softwares, and so we did it with a tracing sheet placed on a Wolf's net or a Schmidt net, as is whatever is required. Now I will you read about it, and I will tell you about a little bit of the basics here. Now, very simple things first. As I told you, the stereo net is projected on a horizontal plane. So this is north, this is east, this is west, south, and this is west. And remember, 90-degree north, 180-degree north, 270-degree north, and 0-degree north. So this plane, remember, it's a projection in the horizontal plane. This plane, this circle, is the horizontal plane. This circle is the horizontal plane. And if you have lines like this, or lines like this, that means straight lines. These are actually projections of vertical planes. Vertical plane, in simple language, means dip equals 90 degree. And horizontal plane, dip is equal to 0 degree. So if I take this one as the horizontal plane and this one as the vertical plane, so you can see that dip is the angle made by a plane with the horizontal measured on a vertical plane. So these are essentially inclined planes or dipping planes. Have you understood? These are dipping planes. So this distance this distance, and this distance are all angles. So here the angle is 0 degree because the dip is 0. Here the angle is 90 degree, the dip is 90 degree. Similarly, between this and this, the angle is 180 degree. Angle is 180 degree. So all planes that go as straight lines are projections of vertical planes like I showed in the last one. And the horizontal plane is the circumference of the circle. And any inclined plane at any orientation is called a great circle. These are all inclined planes. That's the first few things you should remember. Now, any point is a line. Any point is a line. Any point is a line. That line, when it is perpendicular to a plane, that line, when it is perpendicular to a plane, is called the pole. That line is called a pole to a particular plane. How and what to do, I will tell you. But the important point here is, any point is a line. It could be a line, it could be a normal to a plane, it could be anything, but it's a line. It's a line. So these are the things. So if this point is here, that means this lies on the horizontal. This is the horizontal. So the line is essentially horizontal. Lies on the horizontal plane. And this point, if I put it here, this line, this is a vertical line. Have you understood? So, just for example, say for example, if this is the horizontal plane, then the pole to it is this one. Obviously vertical. If you have a horizontal plane, the pole to it should be vertical. So if this is a horizontal plane, then this is the normal to the plane or pole to the plane. And if, for example, a normal lies here at 0 degree, so if a plane has a plunge of 0 degrees, if it lies on the horizontal, and if it is the pole to a plane, then the plane should be vertical and at 90 degrees. So if you have a point on the horizontal and it is a pole to a plane, then the plane has to be vertical because the pole is horizontal. Right? Now, let us try and do a few problems. We will start with simple ones and then we go to slightly complex ones. Let's do this. Say for example, a plane, has the following attitude. This is the strike. 340 degree, dip 35 degree towards east or towards northeast. Okay? You draw the plane and plot its pole. Draw the plane and plot its pole. Now you should, if this is the point, simple question. A plane has the following attitude: 340, 35 degree towards northeast. What does this mean? if this, remember, the strike is perpendicular to the dip. Now, so if this is 340, then this side is 340 minus 120, 180. That means 340 minus 180 is 160. Right? If it's 160, let us get the numbers first. If this is 340, then 180 minus 180 is the opposite end of the strike. So the dip is 90 degree, the dip direction is 90 degree to the strike. So this is the dip direction, 90 degree to the strike. So what are the lines here? So 160 minus 90, 160 minus 90, that is 70 degree north, and 250 degree north, that is the dip line. Have you understood? So, and this is 35 degree, then it's written northeast like that, but it is written, you can either go this way or this way. That means the dip is not exactly 90 degree, it is actually 70 degree. Dip 35 degree towards 70 degree north, that should be it. That's why it's an approximately northeast. It is essentially east-northeast. So let's take the stereogram. So what do? We draw this line, and this is north. So first we draw the strike. See, this is 90 degree, this is 180 degree, so you can have 10 divisions here, and so roughly 160 would be here. And if I extend this through the center, which you always have to do, this is 340. Yes or no? 160, this should be 340. And the dip line should be 90 degree to it. 90 degree means it should be 70 degree here. So the dip line should be like this. This is north 70 degree. And the opposite end is 70 plus 180, that is north 250. Right? Now, so this is the plane. 340, 160, and dips towards northeast. How much? 35 degree. Right now you see. You see, if I take a point here, the dip is 0 degree. If I take a point here, the plane is vertical. So what I do is, I take 35 degree, divide it into 3 divisions. Now I will tell you, it's not a very linear thing. This division is not linear thing. You find out why. It's not a very linear thing. But 35 degree, the dip direction should be somewhere here. So I get 3 points now, and I plot the plane. That's it. So this angle is 35 degree. Because dip is the angle made by a plane with the horizontal measured on a vertical plane, which is 90 degree to the strike. Have you understood? So this is the plane. This is not the plane. This is the strike line. And this is the dip line. But the plane is this. Dip 35 degree towards north 70 degree. Now, what does it say? Draw the plane. So we have drawn the plane. This part is done. We have drawn the plane. And say, plot its pole. Oh, okay. So you have a plane. Its pole should be 90 degree towards it. Isn't it? So, the pole should be on the dip line 90 degree. So if this is 35 degree, then this angle is 55 degree. 55 degree. So if the angle between the pole and the plane should be 90 degree. So you take a point here, and this angle is 35 degree. So this you measure to be 35 degree, so that this angle is now 90 degree. This angle is now 90 degree, and this should be 35 degree. So this should be the position of the pole of the plane. So this is the plane, this great circle is the plane, and the pole to it is here. So this is the plane and this is the pole. Why? How did I draw the pole? I take the dip line, which is 90 degree to the strike line, and this is the point where the dip is 35 degrees. So the angle between the plane and the normal should be 90 degree. If it's 90 degree, then of course it should be 35 degree from here, because here it's 55 degree. So this is the pole of the plane. Right? Let's do the other way. So this is a small problem. So let's say we do it the other way. The pole of a plane has a plunge of 40 degree towards 340 degree north. Now that's where it is. The pole of a plane has a plunge 40 degree. That means this is the amount of plunge. You know, if there is a line, this is the amount, and 340 degree from the north. So what do? This is the magnitude, this is the direction. So let's say this is the stereo plot. So again I draw this. This is north. So 340, this is 270, and this is 360. So 340 should be somewhere here, right? So I draw a line 340, and let me for you extend this. And the plunge, see, this is a vertical plane. What is the amount of plunge? 40 degree from the horizontal on a vertical plane. So the plunge should be on this line, and 40 degree from the horizontal. This is your horizontal, and this is a vertical plane. So from here it is 0 degree, here it is 90 degree, so 40 degree will be somewhere here. So this is 40 degree. Let's say this is 40 degree. Right? Fine. So what did I do? I took 340 and drew a straight line through the center, meaning this is a vertical line. So I have the trace of the vertical plane. And now the plunge is the angle made by the line with the horizontal measured on a vertical plane. So I am on this plane. Now the angle is 40 degree from the horizontal. This is 0 degree. This is 90 degree. So this is roughly 40 degree. So this is where is the pole. This is where is the pole. Now what do I have to find? The pole of a plane, this is information. Draw the plane. Draw the plane. So I found out the pole. Now it says draw the plane. Right? Draw the plane. What do? 90 degree to this is the strike. Remember, this is the dip line, and this is the strike line. So if this is 340, then 90 degree of this will be 20 degree, this one will be 70 degree north, and this one will be 70 plus 250, that is 70 plus 180, that is 250 degree. So that is the pole, that is the strike line. That is the strike line. And now we know that the dip should be on this line. And we know the angle between the pole and the plane should be 90 degree like the last location. So if this is 40 degree, then this is 50 degree, and then this should be 40 degree, and so your point should plot here. And if it's here, so you have 3 points now, you fit a great circle through it. This is your plane. This is not the plane, this is the straight line. This is the straight line. This is your plane, for which the pole is here. Tell me, how can you tell me? But do you understand what I did there? First, I plotted a plane. I gave you the data of a plane, and then plotted the pole. Second, I gave you the pole and asked you to draw the plane. That's all what we did. Now let's do another problem. Let's do another problem. A plane dips 45 degree towards 135 degree north. A plane dips 45 degree towards 135 degree north. A line on the plane has a pitch of 45 degree from northeast end. From northeast end. Now, find the plunge. Find the plunge of the line. That's the question. So, what data he has given? He has given the plane dips 45 towards 135 degree north. Then he says that there is a line on the plane which has a pitch of 45 degree from the northeast end, and find the plunge of the line. Interesting. We should know a few things. Dip, he has given dip amount and dip direction. He has given dip amount and dip direction. And he has given the angle measured by the line from the horizontal on any plane other than the horizontal plane, which doesn't have any strike, and a vertical plane, in which case it will be plunge. So, let's start. Simple again. This is stereogram. Once again, north-south. Now what it says, 135 degree north. That's the dip direction. Okay, so this is 90 degree, and this is 180 degree, and so 135 degree with a bang in the middle. 135 degree north. And I draw a line. I draw this line. What is this line? The dip line. What is this line? The dip line. What is the straight line? Perpendicular to the dip line. So, perpendicular to the dip line. So, the straight line and the dip line are perpendicular. So, if this is 135, if you subtract 90 degree, this is 45 degree. Right? This end of the strike is 45 degree. And this end of the strike, 135 plus 90, that is 225 degree. That is this end of the strike. right? Now the dip of this point is 0 degree. Yes? This we have been talking. And the point here is 90 degree. It says 45 degree towards 135 degree end. From 135, from the horizontal, you plot it close to midway. This is 45 degree. Right? Now you have 3 points. The plane has to pass through the two ends of the strike as well as through this point. There will be a unique great circle that will satisfy this. This will be the plane. This will be this plane. This plane. Have you understood? This is the plane. 45 degree dip. Why are we taking it from this horizontal plane? Because it's an angle made from the horizontal, not from the vertical. So that is why this is 45. Now you see, this end is the northeast end, and this end is the southwest end. What does it say now? This angle, total angle is 180 degrees. I have told you this before. So half of the angle is 90 degrees. Yes or no? Half of the angle is 90 degrees. So now, what do I do? 45 degree. What is the pitch of the line? 45 degree from the northeast end. So this is 90, this is 0, so I come here rough. This is the point on the plane, which is 45 degree from the northeast end. Right? This is the pitch of a line, some line, pitch of a line on the plane having these attributes. And this is 45 degree. Now it says, find the plunge. Plunge. Immediately, it should click into your mind. What is plunge? Plunge is the amount made by a line from the horizontal measured on a vertical plane. That's the point. Angle from the horizontal measured on the vertical plane. Right? So, if this is so, then I need to draw a line, vertical plane, passing through this point. So, here is my line. Here is the vertical line. So, I found out the vertical line. That is the vertical plane in which the point lies. Which is the plunge? The angle made by the line with the horizontal. So this is the plunge. This is the plunge. So normally it would look like that it is right about 40 degrees. This you can calculate actually. 40 degrees. And what is the direction? The direction is this. And what is this? This is 45, this is 90. So I think the plunge will be somewhere around 40 degree towards don't know, looks like 70 degree north. So that is the plunge of the line which has a pitch of 45 degree on this plane. I give you 2 minutes to think about it. Once again, first 45 towards 135 is the direction, amount and direction. From this direction, I draw the dip line, which is this, and I count 45 degree from here. This is 0, this is 90, roughly it should be 45. So this is one point. Where do I get the other points? I take the strike line. The strike line will intersect the horizontal at this point and this point. So the plane that I have to draw has to contain this point, and this one. These 2 points are on the horizontal. This point is not on the horizontal. It's on the plane of this. So now if I draw a line, and there will be a unique line that passes through all the 3 points, that is the attitude of the plane, 45 degree towards 135 degree. Now it says, a line on the plane has a pitch of 45 degree from the northeast. So from the northeast, this is 0 degree. If the pitch is 0, it would have come here. If it is 90 degree, it would have plotted here. But no, it's 45 degree, so I plot it here somewhere. Right? With bisecting, almost bisecting this. And then I come to the question, what is the plunge? Now, the answer is, the plunge of a line is the angle measured from the horizontal on a vertical plane. So, I draw a vertical plane to the point. And on the vertical plane, this angle is 0 degree dip. This is 90 degree plunge. This is 0 degree plunge. This is 90 degree plunge. So somewhere here, and I get this point, this magnitude is 40 degree. 40 degree is the magnitude of the plunge. Which direction? This is the point, this is the direction, and this is north, 70 degree north. So this possibly is the plunge of the line. Let's do another problem. Well, you can go through it several times if you want to understand it. In that way, it is better than a class, because in class, I normally say it once, and if you have not been attentive, you can't listen to it. This one, you can turn it over and over again and listen to what I said. So, there are some advantages of having a video lecture. Okay. There are, let's say, 2 planes. 2 planes. A, 35 degree towards 90 degree. B, 40 degree towards 180. These are 2 planes. Find A, pitch of A on B. Pitch of B on A. C, plunge of intersection of AB. This is interesting. That's one. So that 2 data have been given of 2 planes. One plane dips 35 degree towards 90 degree. Another plane dips 40 degree towards 180 degree. And it asks you, find the pitch of A on B. And then says, pitch of B on A. And then it says, plunge of the intersection of the 2 planes. Obviously, if there are 2 planes, they intersect on a line. So, what is the plane of intersection? That is the question. Okay, so we start. back to the stereogram, right? And we start with plane A, 35 degree towards 90 degree. Just 1 second. North. 35 degree towards 90 degree. This is 90 degree. So, this is the dip line. We are doing for A. I am doing for the red pen, I am doing with A. For A, the dip line 35 degree towards 90 degree, this is the dip line, and therefore this is the straight line. This is the straight line and this is the dip line. So the straight line intersects it at these 2 points. The horizontal at these 2 points. Now what it says, 35 degree towards 90 degree is the dip. Direction is 90 degree, this is a vertical plane. So 35, 0 degree dip here, 90 degree dip here. So 35 would be close to about this point. Right? So if I take these 3, then this is plane A. This is plane A. I erase everything else. What is 35 degree? This is 35 degree. I'm just drawing it because it's important for you to know. This is 35 degree. And this is towards 90 degree. Right. Now it says the plane B. I will do it with the blue. The plane B. So I draw a line like this. Plane blue. What then? 40 degree towards 180 degree north. 180 degrees this here. So this, if I draw, this is the dip line. Yes or no? This is the dip line because this is 180. If this is the dip line, this is the straight line. This is the straight line. So if this is the straight line of plane B, then I get 2 points, one here and one here. Now, but that is not the issue here. Here it is 40 degree towards 180 degree. So it should lie on the dip line. So if it's on the dip line, then if it was here, the horizontal, then it would have been here. If the line was vertical, the point would have been here. That is 90 degree dip, but it is round about 40 degrees. So that is, this is the plane. This is the plane. This is plane B. This is plane B. And this is plane A. Now let's answer the last question. Let's answer this question. You see, the 2 planes intersect at this point. Yes or no? There is only 1 point where the 2 planes intersect. Have you understood? Yes or no? Right. So if that is so, I have to find out the plunge, isn't it? Plunge is measured from a line from the horizontal on a vertical plane. So now I have to draw a vertical plane through the point, which is fairly easy to do. It's fairly easy to do. Now you see here. What is this? This point I want to find out, isn't it? What is this? This is the plunge amount. And what is this direction? Plunge direction. Have you understood? So this is the plunge amount, and this is the plunge. This is the plunge amount, and this is the plunge direction. So you can see what is the plunge amount. It's roughly around 40 degrees. Plunge amount is roughly maybe 35. I don't know. I have to find out. 35 degrees, and the plunge direction is towards. This is 90. This is 180. This is 135. So maybe 120 degree north. That's the answer to question C. 35 towards 180 degree north. Remember what you did. You first found out the two planes. Yes, of course. And then what you did was, you drew a line, straight line through it, which is essentially the trace of a vertical plane. So that your point lies here. And then you measured this angle. Why did you measure this angle? Because this is horizontal. From the horizontal, this magnitude is roughly around 35 degrees. And the direction, you did it from the azimuth. This is 90, this is 180, this is 135, this is close to 120 degrees. So the plunge of the intersection of the two planes are 35 degrees towards 120 degree north. Now, we come to the other question. See here. Be very careful as to what I'm doing. Be very, very careful. What does it say, the first question? What is the pitch of A on B? That means what? B is the plane. B is the plane. The plane that is important for question 1 is B, this plane. Right? This is the plane. Pitch of A on B. That means this is the plane B, and it's finding out this angle. This point. This point is what? The intersection of A on B. Have you understood? This point, if you take this plane if you take, then this point gives you the intersection of plane A on plane B. Have you understood? So what is the pitch? This is 90 degree and this is another 90 degree. So you can see the answer would be, say, 30 degree. But that's a wrong answer. You have to say from which end? From 30 degree from east. That's okay. 30 degree from east. That is the pitch of A. That means the intersection of A on plane B. Here your measurement plane is B. You're measuring the intersection of A on B. And that is 30 degree from east. But when you ask, okay, this is B. So you must try and understand. This is the pitch of A on B. That is 30 degree from east. Now it asks you the pitch of B on A. Now your plane is A. So this is your plane now. Your plane has changed. Your plane has changed. Now this is your plane. And it is asking you the pitch of B. That means it's asking you the pitch of this point. So is it this or is it this? This is impossible because this is more than 90 degrees. Obtuse angle pitch is always an acute angle. So what it says is, this is the pitch. Have you understood? This is the pitch. This is the pitch of B. Pitch of B. Intersection of B on A. That is important. So now here you can see, if you take this and this, it's almost 90 degrees. And so this is roughly 60 degree from south. That's it. 60 degree from south. So those are your answers. Those are your classic answers. So you must be very clear here. What is the plunge of intersection? Once you caught a plunge, you see the problem is this point lies on, because it is of intersection of A and B, they lie on both A and B. Have you understood? This intersection line, whatever that line is, lies on both A and B. So if there is a line on a plane, you can find a pitch on both the planes. So the first question says pitch of A on B. So the plane is B and it is the intersection of A, and this is the amount. This is the amount of the pitch. This is the amount of the pitch. This is 30 degrees from the eastern. But when it says pitch of B on A, then the plane is A. So the plane is A. And this point is roughly 60 degree, because this is 90 degree. This is roughly 60 degree. It is 60 degree from the horizontal. So it's 60 degree. It's not this angle. It's not this angle. It is from the horizontal. This is the horizontal. So this is 60 degree from the south. The important point here is both the planes are intersecting. So the line of intersection is on both. And since both planes have different orientations, the pitch of the single line will be different in both the planes. Okay, I think we stop here. I will upload okay, I think we stop here, and I will upload these videos if possible tonight or tomorrow morning to your Google Classroom. I think after this I will do 1 or 2 more problems, and then I will switch to the normal things. So it will take another 2-3 classes. I think 3 classes would be enough, and we will finish it in the next 3 classes after this. Right? Thank you.